In this video, you will learn how to solve stoichiometric problems perfectly. In solving stoichiometric problems, you will use a series of conversion factors to get from the units of the given substance to the units of the wanted substance. But why study stoichiometry? There are a number of reasons why chemistry students study stoichiometry. I'd say the most important is the ability to make useful predictions. Stoichiometry allows us to make predictions about the outcomes of chemical reactions. Making useful predictions is one of the main goals of science, the other being the ability to explain phenomena we observe in the natural world. A stoichiometric ratio comes into play when talking about the relationships of elements or molecules in specific problems. This is the exact ratio between the coefficients of the reactants and products needed for a reaction to proceed normally. Now, let's start solving stoichiometric problems. What mass of chlorine does the decomposition of 64 grams of gold chloride produce? Before anything else, before you start solving, identify the given first, which is 64 grams of gold chloride. Then, determine the unknown or what is being asked in the problem, or what you are going to find or solve, which is the mass of chlorine. So, let's start solving. Here's the solution. First, write the balanced chemical equation. If it is not yet provided, we have the reactant, gold chloride, decomposed into gold and chlorine gas as the products. Recall how to balance a chemical equation. After the trial and error in balancing, we have the balanced equation 2AuCl3, then 2Au and 3Cl2. Second, always start your solution with the given 64 grams gold chloride. Next step, what should be written above is the mole of gold chloride, then below is the molar mass of gold chloride. Why is it mole is written above and grams below? That is for us to cancel out grams of gold chloride. Now, let's proceed. Since mole is written above, next conversion, mole should be written below, again, for us to cancel out mole of gold chloride. In this part, what we are going to do is to apply the concept of stoichiometry. We are going to apply the ratio between gold chloride and chlorine gas as what we are trying to find, based on our problem. The ratio that we are talking about will be based from the given balanced equation, that is 2 moles of gold chloride is to 3 moles of chlorine gas. We are almost done. We are now on the last part. The problem asked for the mass of chlorine as one of the products. We are just going to continue the solution. Since we have here 3 moles of chlorine gas, same should be written below, mole chlorine gas. Lastly, get the molar mass of chlorine gas, which is 71 grams. Excellent. Then, cancel out the mole of chlorine above and below. Now, get your calculator and solve. That's 64 divided by 303 times 3 divided by 2 times 71 equals 22.5 grams chlorine gas. Use the equation below to solve the problem. If 2.5 moles of glucose reacts, how many moles of carbon dioxide are produced? Using dimensional analysis, you can use the stoichiometric ratio to find the solution to this problem. By looking at the coefficients, you can see that for every 1 mole of glucose, 2 moles of carbon dioxide are produced. Using this ratio, you can figure out how many moles of carbon dioxide are made from 2.5 moles of glucose. Let's solve it the way what we did in the previous equation. Again, check the chemical equation. If it is already balanced, then identify the given and the unknown. Take note that the given is in moles already, so it is not needed to convert it to grams. After that, we can now start making the solution. Again, in making the solution, always start with the given, which is 2.5 moles of glucose times 2 moles of carbon dioxide. Next step, divided by 1 mole of glucose. Take note that 2 moles of carbon dioxide and 1 mole of glucose is the ratio from the balanced equation. So, cancel out moles of glucose, remaining moles of carbon dioxide, to answer the question. Now, get the calculator and solve. 2.5 times 2 divided by 1 is equals to 5 moles of carbon dioxide are produced in the decomposition of glucose. Let's use the same equation. How many grams of glucose was initially used if 10 grams of ethyl alcohol was produced? Similar to the previous problem, by using the stoichiometric ratio of reactant to product, you can find the answer. Dimensional analysis is used to go from grams of ethyl alcohol to molar mass, to mole, or stoichiometric ratio, and back to grams. Let's start solving. Write the given and the unknown first, before you start making the solution. Given, 10 grams of ethyl alcohol. Unknown, grams of glucose. Let's start making the solution with the given. 10 grams of ethyl alcohol. Since our given is in grams of ethyl alcohol, then grams of ethyl alcohol should be written below. That is the molar mass of ethyl alcohol, for us to cancel it out. Above is 1 mole of ethyl alcohol. In other words, 1 mole of ethyl alcohol is equals to 46 grams of ethyl alcohol as its molar mass. Next would be the stoichiometric ratio between the moles of ethyl alcohol and glucose, based on the balanced equation. That is 2 moles of ethyl alcohol is to 1 mole of glucose. You can now cancel out mole of ethyl alcohol. Next would be the molar mass of 1 mole of glucose. That is 180 grams of glucose, that should be written above. Then, cancel out mole of glucose, remaining grams of glucose to answer the problem. Now, get your calculator. 10 divided by 46 divided by 2 times 180 equals 20 grams of glucose was produced. How many carbon dioxide molecules are produced when 0.75 mole of propane is combusted according to this equation? C3H8 plus 5O2, then 3CO2 plus 4H2O. The approach here is the same as what we did previously, though the absolute number of molecules is requested, not the number of moles of molecules. This will simply require use of the moles to numbers conversion factor, Avogadro's number. Now, as always, identify the given and the unknown. Let's start with the given, 0.75 moles of propane. Note that the given is in moles already, so the next step would be the stoichiometric ratio between the given and the unknown. That is 1 mole of propane is to 3 moles of carbon dioxide. The next step now is the equivalent Avogadro's number of a 1 mole of carbon dioxide. Do the cancellation of units. Then, calculate 0.75 times 3 times 6.022 times 10 raised to 23 powers. And the answer is 1.36 times 10 raised to 24 molecules of carbon dioxide. I guess you are ready now. It is your turn. Give what is being asked in the following problem. Kindly comment your answer. Thank you. Hope you learned something valuable today. Please don't forget to like and share this video, and if you are not a subscriber yet, please click the subscribe button and the notification bell. Learn chemistry with Sir D.